moving boundary work, okay, or PDV work. So associated with the expansion and compression of a gas in a piston cylinder device, piston is allowed to move a distant ds in a quasi-equilibrium manner. The differential work done during the process is delta work of boundary. Okay, work of boundary equals to FDS. Okay, so this is the ds, the changes of distance, equals to F is also equals to PA, pressure and area. Okay, PA ds. Okay, but A ds equals to dV, right? The volume. Okay, so we will have this. So delta work of boundary equals to PdV. Okay, so valid for quasi-equilibrium process. P is absolute pressure, dV is volume change. This is positive expansion. Okay, expand, the gas is expand. Okay, this is expansion. Okay, but if it's compression, when the lid going down, so it is negative values. Okay, compression. So to calculate the boundary work, the process by which the system change states must be known. Functional relationship between pressure and volume during the process. Okay, so P equals to the function of volume should be available. So what is the equation of the process path on a PV diagram? How do we relate that? Okay, the boundary work is actually area under the process curve plotted on a diagram. So if you have PV diagram, okay, so we have, this is the piston. Okay, so when you have expansion occurs in here, right? Expansion occurs in here. Okay, so this is your dV. The changes of volume occurs in here. Okay, but this is also dA. Okay, dA equals to PdV. And the process path, the whole process is from state number 1 to state number 2. But what if we just want to identify the... So by using total boundary work from initial state to final state, work of boundary equals to, okay, PDV from state 1 to state 2. Okay, so we are going to use this equation. Okay, note that pressure is the absolute pressure and is always positive. Okay, pressure is always positive. When dV is positive, work boundary is positive. But when dV is negative, work boundary is negative. It means when dV is positive, it's going to expand, expansion. Okay, expansion. Okay, so dV final minus the initial, so we get positive value. But if dV is negative, it means compression from here to here and backward. Okay, work boundary is negative. Okay, each process gives a different value for the boundary work. So even though we are going from the same state number 1 to state 2, but the journey is coming from different path. Okay, path A, process B, process C. So it might consume, it might using different value of work. Each process gives a different value for the boundary work. Okay, so the boundary work done during a process depends on the path followed as well as the end states. The net work done during a cycle is the difference between the work done by the system and the work done on the system. Okay, process B 1 to 2, process A 2 to 1. And the net work is for a cycle. It's the difference between the work done by the system. Okay, so PDV, work boundary is equal to how much is the P, pressure, how much is the dV.